We all know the coldest temperature we have recorded was -89 degrees Celsius and the hottest was 57 degrees Celsius. But what if we take into account all of the temperatures over geological time? I will not be discussing the hottest temperature ever, as it is easily computed to be around 9,000 degrees Celsius during the impact with planet Theia. It was so hot that it would have appeared brighter than the sun at more than 3 million kilometers away. The moon at its current distance would have been heated to more than 400 degrees Celsius. We now need to focus on the coldest the Earth has ever gotten. A logical place to start would be the last glacial maximum, when the northern hemisphere cooled by about 15 degrees. Interestingly, the coldest place on Earth, Antarctica, probably didn't change much in terms of climate during the Ice Age. Some places may have even been warmer. That allows us to focus on Greenland, which cooled by about 20 to 30 degrees Celsius. This gives it a minimum winter temperature of -95 to -100 degrees Celsius. This means that central Greenland and northern Canada may have been cold enough for winter-long carbon dioxide ice caps like the poles of Mars. But has it gotten colder? 2,426,000,000 years ago, photosynthetic organisms rapidly diversified and began to produce oxygen on a scale never seen before. Oxygen is the second most powerful oxidizer and therefore likes to destroy the structures of organic chemicals. At the time, no lifeforms had adapted to the presence of a lot of oxygen. Oxygen is a far more powerful oxidizer than even chlorine. Organic chemicals are unstable in the presence of oxygen, and as a result, 99% of all life died off. At the time, nothing but methane was keeping the Earth from freezing over, as the sun was not as luminous. And oxygen reacts vigorously with methane, turning it into CO2 and water. The water precipitates out and the CO2 cannot sufficiently warm the planet anymore. As a result, the planet's average temperature dropped to -45 degrees Celsius. Extrapolating the cooldown to the polar caps, we can guess that they may have been as cold as -100 degrees Celsius on average. This is cold enough for chlorine, bromine, xenon, radon, and mercury to be frozen like a rock. It took the combined efforts of millions of heat-absorbing bacteria and erupting volcanoes 200 million years to thaw the planet. And this wasn't the last time the planet froze over. It happened again from 700 to 650 million years ago.